So I am in the San Francisco Volcanic field, located north of Flagstaff, and for the past couple days I've been receiving training on field geology to help me better understand how we're going to plan and execute spacewalks when we go back to the moon. You know, I've got a lot of experience with the space shuttle and space station spacewalks, but when it comes to surface operations and doing science objectives, it's a whole different game, and so it was really valuable to come out here and get some field experience. And just to give you an idea of why they call it a volcanic field, well, you can see behind me a massive lava flow, and then as I pan around this way, in the distance you can see various volcanic cinder cones. So I came back after our field training. I wanted to do a little exploring and just go at my own pace and just take another look around. So I'm at the base of SP crater. There it is in the background. I'll let you figure out what SP stands for. I might tell you later. But you can see how after the cinder was formed, then this lava flow came out and went kind of in a northern direction. And it's just a massive lava flow. It goes on for miles. And obviously it's very new because of the dark color and lack of long-term erosion and plant vegetation. But then as you progress more westerly from here, you'll see other lava flows, and they've got more erosion and more plant life, so you can kind of take a guess as to the age. Of course, if you really wanted to know, you could go date the rocks using some lab equipment. But just coming out and taking a look, you can get a basic idea of what might have happened here in the past. Alright, so I've come just a little bit west. You can still see the crater, or this SP crater behind me there. And then of course the lava flow that I showed you that goes north from here. But then already you can see another lava flow headed north here, and then if I turn, you can see kind of a little bit west of me there's another lava flow that way, and then just south of me back up on the hills there's some other lava flows, and part of our training was to compare the mineralogy between these different flows, looking for different color crystals, different quantities, how many of the crystals are present on average per sample, looking at the vesicularity, how much bubbling there is in it. All of these things can be compared to try to determine if they're the same event, same unit as they call it, or if they came during different events. So it's pretty interesting that these lava flows can be so close together, and yet you can tell that they are different. I drove a little bit farther west. You can see SP in the distance. And then if you notice, between me and SP, there's another crater, or another cinder, and it's kind of split into two pieces. There's some different theories as to how that happened. It turns out that if you look back the other direction, it's a little hard to see from where I'm at right now, but there's a fault line. So maybe after that one formed and spewed its lava flow, maybe it was split apart by the fault, by plate movement, or maybe just the way that it deteriorated, it split into a couple directions and let the lava flow out the other sides. I'm not really sure. But the other reason I wanted to stop here is to show you this area over here. You can see the rocks are quite a bit different. They're kind of a light yellow color, and it turns out they're limestone. And so this region used to be a seabed, and there's sandstone and limestone that was built up over time through sedimentation and compressed from the water, the weight of the water. And then later on, millions of years I guess, these volcanoes happened, and they deposited lava, basaltic lava, on top of the sedimentary layers. And then also, over time, I imagine there was some erosion, water flowing out from the seabed as things changed, as the water levels changed, and that cleared out some of the lower and flat areas. So I might be getting some of this wrong, but this is some of the stuff that we were learning over the last couple days. Hopefully I'm doing my instructor proud. But it is interesting to just look at the different types of rocks and have a basic, idea of why they're different. I guess I should come around here and show you some of the other older lava flows, older than SP. You see how there's just random outcroppings left over with a lot of kind of flat areas in between. But if you break open some of those rocks with a hammer and take a look at the different minerals inside, the different crystals, you can notice that, for example, these outcroppings tend to have a lot of olivine, which is kind of a greenish crystal, whereas the outcroppings, when you break apart the rocks over at SP, you tend to get less of a high percentage of olivine, but you'll get some other black and white crystals. I think pyroxene is the name of the black one. So because you see the different distribution of the types of crystals, you can tell that most likely they're from different events. So I thought that was really interesting. past further west from SP, and then the other cinder I pointed out earlier that is kind of split in halves. Our group called it the snail. That's just the name we came up with. Every other group in the trading exercise came up with different names. I don't know what the official USGS name is for it, but it just helped for us to kind of name things and be able to talk about things in a context the group understood. So now I'm traveling kind of southbound, and so you can see, you can almost see that fault line that we found, maybe. But then, kind of over here to the west, you can see a whole bunch of outcroppings, and you see what I mean about how it's very kind of wide and spread out, kind of dispersed outcroppings. But we sampled quite a few of those, and they were distinct from the other lava flows. And of course, way in the distance, you can see other volcanoes, other cinders that probably contributed to these flows. So I'm going to keep heading south. You can just start to make out Colton Crater right about there. So that's another volcano. That one must have been a big event because it really blew its top off. That was not part of our mapping area, so that's why I'm hoping to go take a look at it today. So we're at the southern face of the volcano that's just southwest of SP, and this is the one that we called Snail. And you can see distinctly how it's split into two sections. So yesterday we actually hiked up to the western peak just so that we could get a good view of the rest of our mapping area. You can't really see it from here. But it really gave us a good overview of what we were trying to map out. And then to the south, this was not part of our mapping area for our exercise, but this is Colton Crater. That's the one I was describing that, you know, must have been a pretty big event for it to be that ripped apart on top. We're on the east side of what we were calling Snail, and kind of the southeast of SP, so you can see pretty well how there's much more vegetation, and it's kind of a reddish color. And then as I pan to the north, you can see SP is very distinctly different. It's kind of a darker black predominantly with some reds, and much less vegetation. So I drove starting around the north side of SP, and I've been taking you guys around the west side, down around the south, and there is a road up to the top of the volcano or cinder that's just to the southwest of SP. From the north side, it looks really rutted. There's actually a sign that says don't drive that, so I didn't want to add to the erosion, but on the east side there's a road that looks in much better condition. You know, there's a little bit of water runoff, but I had no trouble getting up it. I don't think I ever lost traction once. But up here, it's an amazing view. So behind me, I've got SP, and then to the north, you can see the lava flow. So bear with me, I'm going to move the camera around so you can get a really good view of that. Here's SP. And then to the north, hopefully you can hear me over the wind. This is all the lava flow from SP. And then in this direction, you can actually see a fault line right there. I think it's a fault line. And notice how the limestone beds are kind of raised up to the left, and then kind of lower to the right. So that's why we thought that would be a fault line. And you can actually see where the flow from SP fell into that fault line. So that's one reason why we think that the SP flow happened after that fault shift. And that's why we think also the fault shift happened after the formation of those limestone beds. As I pan to the west, you can see more of the older lava flows. To the southwest, you can see more volcanoes, more lava flows. And then here's what we were calling Snail. You can see how it's split in half. And then Colton Crater in the distance. And then beyond all that, you've got Humphreys Peak and a bunch of other mountains and volcanoes. So hopefully this gives you an idea of the variety of terrain and geology out here. You know, I only have a very small understanding of it just from 2 days of training, but I was really appreciative that we got that training. And it's just really cool to explore up here. So I drove partway up to the base of Colton Crater. I thought about maybe driving up it, but the ruts on that trail are pretty deep, and it's obvious that every time someone drives it, it kicks debris down the hill. So I chose to park and hike in. But it's you know, it's pretty cool in here. Yeah, so there we go. Now I think, if I remember right from our training, this crater is, you know, tiny in comparison to some of the ones that are on the moon. If you've ever been to Meteor Crater, kind of east of Flagstaff, that one's 1 kilometer across. That one's more representative of some of the kind of smaller to medium-sized craters. And then from what I understand, Shackleton Crater on the South Pole, for those of you in Houston, is about the size of the 610 loop. So, you know, if you look behind me and you think, well, this is big and steep, where they're targeting for the lunar missions, that crater is, I forget how many kilometers across, but it's roughly the size of the middle part of Houston, the 610 loop, and I think it's 3 times as deep as the Grand Canyon. So imagine having to hike in there in a spacesuit and then hike back out. Yeah, I'm not sure about that, but we're going to keep planning and figuring out what's a safe thing we can do, maybe exploring along the rim without going down inside. You can see there's some kind of newer activity since it originally blew, because it's kind of a darker material, less vegetation, less erosion. And then let me show you some of the samples that I just grabbed with my hammer. Let's see if I can get you some good lighting here. So here's a little piece. Can you see that? You see all the crystals in there? Quite a bit of the green crystal, which I think is olivine. Maybe some white ones. I'm not sure what the name is for that. And then here's another sample that looks a little bit different. It looks, I don't know if it formed more quickly or slowly. But it's got some larger size crystals, so that tells me that I think it formed more slowly, it cooled down more slowly. If I remember right, look at the size of that one right there. Those ones are black. There's a black one there. That one there looks kind of copper in color. The black ones, I believe, are pyroxene, I think. And then one more from the rock right next to my backpack there. See, this one's got a little bit more shoe fly. This one's got a little bit more porousness, so vesicularity, I think is the right word. And then it's got some layers in here. And so I think, if I remember right, that's due to it being shot out quickly, and it kind of stretches as it cools. But I'm not sure about that. I think that's what they said yesterday, but don't quote me on it. There's some gaps in there, some little holes, air pockets. So this probably was formed in the initial formation of the cone with all the gas bubbling up. And then the other samples probably were formed as the lava kind of oozed out, I think. Anyway, I got some souvenirs I'm going to take home and share with everybody, and try to share what little I learned over the last couple days. So I realized I forgot to mention one detail that's kind of interesting. So in the Apollo missions, they landed in the equatorial region. So if you think about it, like near the equator on Earth, you get sun for most of the day, whereas when you're up near the North Pole or down near the South Pole, depending on how the Earth is tilted, you may get really long or really short days. For the moon, during the Apollo missions, they chose equatorial, I think, just so that they'd have good illumination from up overhead. But for the next missions, for Artemis, they're going towards the South Pole. And so since they're going towards the South Pole, so it's about 5 p.m. and it's going to be sunset here in about an hour or two. And can you see the shadow that's covering at least a third of the crater? But now imagine the sun being pretty much at sunset. And so that shadow is just going to cast across most of the crater. And it's that way all the time, because the way the moon is, it doesn't have the same fluctuation like the Earth does with our seasons. And so it's always shadowed, so it's very, very cold and very, very dark. So that's going to be a challenge for the suit engineers, the tool engineers, all the imagery, for the lander even. Just something interesting to think about. So I'm set up for camp for tonight. I decided to just stay down at the base of Colton Crater. I'm trying to find a little bit of shade from the wind next to some of these scrub bushes around here, because it's been pretty windy the last couple days. But it's been really good to visit this area. I don't think I mentioned this before, but about a decade ago, I was involved in some analogs. It was called Desert Rats, and originally that program was pretty small in scope. It was just the next generation suit team working on their design and doing field tests out here in the lava flow and rough terrain, just seeing how the mobility worked out in the field. And then eventually that grew. More teams joined in on the fun. There was development with the small pressurized rover. And I guess at its height, it in the last few years, the science team of the planetary geologists and the ops team with people like myself joined in to try to make it more of an integrated simulation. And I think the last analog they did, we ended up having 2 rovers, each with 2 crew, and then we had several people in an ops trailer coordinating all of the operations. And so that was it was really fun to work on that. I think we learned a lot. Of course, that was earlier on in my career, and I feel like I didn't know near as much back then. And it was really good to come out here and learn a little bit, just a glimpse of field geology. I really wish I had had the opportunity to do this before I tried to lead the operations of that analog. I think we did a great job, everybody as a team, but I think having this training now makes me better prepared for the different style of operations. And it's always been kind of a back of my mind goal to come back out here and visit the area, and so it's pretty cool. I get to spend the night here, nestled in with the volcanoes where we did all that field testing. And as we ramp up for Artemis, hopefully we'll be back out here and do some more training and maybe some more analogs. But I'm just waiting for the sun to set, doing a little reading. Got the crater behind me, and then I'll turn the camera around here in a second, but I can see SP crater and my friend the snail. And it's nice and quiet, just a little bit of cold breeze.